Chapter 5, Section 5, Inequalities in one triangle. This first statement says if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. Remember, a triangle has three sides, and this is going to go in order. So the largest side is going to be opposite the largest angle. The smallest side is going to be opposite the smallest angle, and the middle length side is going to be opposite of the middle measured angle. The next statement says if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this works both ways. If you have one larger angle, then the side opposite of the larger angle is going to be longer. If you have a smaller angle, the side opposite is going to be the smallest side, and then of course the middle 8-degree angle is going to be opposite of the middle length side. This example asks us to write the measures in the triangles in order from least to greatest. Notice example A. We are given the angle measures, so we want to order the side lengths from least to greatest. Notice that we are given three angle measures. A is 23 degrees, B is 111 degrees, and C is 46 degrees. The sides opposite of those angles are going to be in the same order as the angles are. So if angle A is the smallest angle, then the side opposite BC is the smallest side. The middle degree angle is 46 degrees, angle C. The side opposite of that angle is side AB. And then my largest angle is 111 degrees, which is opposite of side AC. If you look at example B, we're given the side lengths of the triangle TUV. Notice TU has a length of 7, UV has a length of 10, and TV has a length of 11. In this case, I want to order the angles from least to greatest. If TU is my smallest side, then the angle opposite angle V is going to be my smallest angle. The next smallest side is 10, UV, which is the opposite of angle T. And then my largest side is TV, which is 11, which is the opposite of angle U. The next example says the figure below shows the side view of a chair. In the figure, side JL is congruent to segment LK, and side JK is less than JL. What can you conclude about the angles in triangle JKL? If you remember the base angles theorem, when we have two congruent sides, we also know that the angles opposite of them are congruent. So the angle opposite of JL is angle K, and the angle opposite of LK is angle J. Because the sides are congruent, we can say that the angles J is congruent to angle K. We're trying to compare all three of the angles, so we also need to look at angle L. We know that J and K are going to have the same angle measure. If you look at angle L, it is opposite of side JK. If you look at the whole triangle created, JK would be the smallest side, which means angle L would be less than angle J and angle K. So angle J and angle K are congruent, and both of those angles are going to be greater than the measure of angle L, because angle L is opposite the shortest side. The exterior angle inequality theorem says that the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle is greater than the third side. So if you look below at the triangle, that means that side AB plus side BC has to be greater than the third side AC. It also has to be true all 3 times. So it also has to be true that AC plus BC is greater than AB, and that AB plus AC is greater than BC. Now notice that this does not say greater than or equal to, it says greater than. So if you get a sum and it is equal to the third side, then it is not going to be able to be the lengths of a triangle. This example says, is it possible for a triangle to have these side measures? The first one gives us side lengths of 3, 3, and 8. If you look at 3, 3, and 8, we need to be able to add any 2 of those and it be greater than the third side length. So if you like, let's just take the first 2, 3, and 3. The sum of 3 and 3 would be 6. 6 is not greater than 8. So in this case, these measures could not be the measure of a triangle, the side measures of a triangle. If you look at the next example, we're going to do the same thing. Take any 2 side lengths. In this case, I'm just going to take the first 2 again. In this case, we have 6 plus 6. Well, 6 plus 6 equals 12, and my third side measures 12. Remember I said that it has to be greater than the third side, not equal to. So in this case, again, because 6 plus 6 is not greater than 12, these could not be the side measures. So the answer is no. If you look at the next example, we're given side lengths of 9, 5, and 11 inches. Take 2 of the side lengths and see if they are greater than the third side length. So if we have 9 plus 5 is 14, and 14 is greater than 11. So far, one of them works. Take another 2 side lengths. In this case, let's take 5 and 11. 5 plus 11 is 16, which is greater than the third side, which measures 9. So far we have 2 that work. Check the last one. We can add 9 plus 11 is 20, and 20 is greater than 5. So again, that works. All 3 combinations are true, so this answer is yes. It is possible for a triangle to have these side measures. The last example says a triangle has one side of 8 centimeters and another of 17 centimeters. Describe the possible lengths of the third side. The third side, remember, it's going to have to be a number that when we add any 2 numbers together, the third side is greater than their sum. So if you look at the smallest side that we're given, it's 8 centimeters. Whatever side length we have for my third side, it has to be greater than what number? It has to be greater than 8 plus whatever number we choose has to be greater than 17. So what number plus 8 would be greater than 17? And it would be any number that is greater than 9, because 8 plus 9 is 17. We actually need it to be greater than 17, so it can't be 9, but it could be anything over 9. But it also has to be true that when we add 8 plus 17, this side length has to be less than that number. Well, 8 plus 17 is 25, so we know that the third side also has to be less than 25. So the possible lengths of the third side would be any number between 9 and 25. So if you chose 10, all 3 of the statements would be true. 10 plus 8 is 18, which is greater than 17. Then you could do it 2 more times with the different combinations. So any side length between 9 and 25 could be a triangle with the 2 sides 8 and 17 centimeters. Today's assignment is on page 298. It's numbers 6 through 25 and 34 through 37.